this.
You're walking home, and you notice that your can of beans suddenly has a puncture.
Give me them beans, boy. Get away!
As they drain from the can at a rate of 46 centimeters cubed per second, they create a conical pile on the ground with a fixed height of 4 centimeters.
My beans!
Wanting to be sure you can quickly recollect your beans, you decide to calculate how fast the radius is expanding. How fast is the radius expanding when it is equal to 6.5 centimeters? Your first step in any related rates problem is to determine what formula you need to be using. In this case, we'll be using the formula for the volume of a cone, which is V equals 1/3 pi r squared height. Now, your next step is to draw a diagram and fill in the variables that you know. So in this case, we can draw a cone, and we know that it has a fixed height of 4 as the problem stated. We also know that the volume, or derivative volume with respect to time, is increasing at 46 centimeters cubed per second. And we know that the radius at this moment is 6.5 centimeters. This means that we need to find dr with respect to time.
Now that you have the equation you're going to be working with, you can plug in any and all constants. You should end up with velocity equals 4/3 pi r squared. Now that you have that equation, you can take the derivative. Now that you've taken the derivative, you can plug in any changing values. Take the derivative with respect to time, and you should end up with dv over dt equals 8/3 pi r times dr over dt. Once you've plugged in your values, solve in terms of dr over dt. You should end up with 138 divided by 52 pi, which should equal about 0.8447 centimeters per second. Now you can recollect your beans.